Hello, I'm Reza Lamei, and in the second video of my tutorial how to create a pre-stressed concrete model using ANSYS Mechanical APDL, I'm going to continue with creating the model and defining the basic specification of the structure like element type, real constant, and material properties. In the first video I define and create all of my geometry, and you can see the geometries here. I want to briefly summarize the points because the points that I'm going to discuss can be found in some other references and YouTube videos. First, I want to start with material properties. For the first material, I'm going to define my concrete. I have to follow these trend: non-linear, inelastic, non-metal plasticity, concrete. It asks me to insert a set of elastic properties for my material. My concrete is 40 megapascal, and you have to calculate the elasticity modulus because there are some relations in order to calculate these modulus. I calculated before, and Poisson ratio for most of concretes are 0.2. It is the main menu of the concrete, and you can define the basic specification of your concrete here. ANSYS uses smelt cracking theory to model concrete and also the cracks, and in the procedure of the smelt cracking, two multipliers will apply in some part of the stiffness matrices, whether your cracks are open or closed. And also for opening or closing the crack, it has some relations. You can see all of the details in the help, but I want to summarize it for you. Open shear transfer coefficient usually between 0.2 to 0.3. I consider it 0.25. And closed shear transfer coefficient, because when your shears your cracks when closed, your stiffness is greater than when your cracks are open, and it usually varies between 0.9 to 0.8. I consider 0.85. And these two are your main strengths of your concrete. It's the tension strength and it is the compression strength. Usually tension strength is usually 1/10 of your concrete strength, compression strength. For my concrete is 4D, so my tension strength is 4. You don't need to fill other blanks, and I press OK. And for density, density for concrete is, excuse me, it's 9. Take note on the power of the 10. It usually make you mistake. You have to consider your units. My units are Newton and millimeter. Okay. And the second material is I'm going to discuss is my steel. I have two forms of steels. One of them for my conventional rebars, like shear rebars or thermal rebars or shrinkage rebars. I don't want to model them exactly. If you want to model them discretely, you have to go to this part, and you have here reinforcement. You have to define them in reinforcement. You have to define the direction and also the cross section. I don't want to use this specification of the software. My concrete can model the rebars as a distributed part of volume, uniformly dispersed, all around your elements, and I want to use this specification. And also it can model the non-linearity of the rebars and steel. So I want to define the material properties of my conventional rebars. In this part, new model, new material. Again, it is non-linear, it is inelastic, it is rate independent, and is plasticity. I want to define it bilinear. My elasticity modulus and Poisson ratio. Yield stress, usually my steel is A3 for rebars, depend on your steel. Okay. And for my pre-stress concrete, pre-stress steels, I have to define another material. Again, I have to follow this trend, but instead of bilinear, I want to define it multilinear because I need more exact. I want to be more exact about my pre-stress concrete, pre-stress steel. Again, the same. Okay, and it's like a curve fitting. You have to insert point by point the stress strain graph. You have to find the graph of your steel. I found it before, and I have to insert it point by point. And the first point must be lead to a slope that is exactly equal to your elasticity modulus. So for example, if I input 0.007, my stress must be 1400. Again, and excuse me, and my ultimate strength of the steel. You can see the graph here. Okay, I defined all of my materials, so I'm going to move to element types. Excuse me, volumes. So I want to define the element types. For element types, I have volumes. For volumes, I have to choose solid elements, and from these solid elements, usually my concrete must be block shape elements, and I have to choose between these three elements. And among these three elements, I see that it is a concrete, and for concrete, I just have to use concrete 65, because the other elements, the other two, are not able to model cracks and will not work for my concrete. Again, I need another solid, and it is solid 185, because I have some block at the end of my tendons, and I want to model them as some steel blocks. These blocks help me to reduce the stress concentration in this part of my structure. It has a complicated detail, but I want to simplify it as a steel block. Okay, and for my tendons, I have to choose link elements. I can use either beam elements, but usually link elements are more better. That's it. Okay, and real constant. Real constant means the specification of my elements. I need two real constants for my elements. The first is for my tendons and also for my concrete. The first I'm going to discuss is for my concrete. In this menu, I can define the rebars that I discussed before in three directions. Volume ratio, I defined it before. Volume number is 2. Volume ratio usually for these kinds of rebars is 0.5% of your volume, and theta. You can see the help in order to clarify about the theta and phi, but I want to summarize it for you. When you insert theta 90 and phi 0, your rebars will along y direction. If both of them are 0, your rebars will along x direction, and if theta is 0 and phi is 90, your rebar will along Z direction. Here I need sets of rebar along Y direction and X direction. And for Z direction, my pre-stress cables will work. Again, 94 Y, and that's it. Also, sometimes, for example, your volume is not exactly along the main directions and axis, so you can define a local coordination system, and that will work in your local coordination system. I will discuss about the local coordination system further. Okay, I defined my rebars and volume ratio of my rebars, and the second real constant is for my link elements, the cross section of my cables, and also I can define whether my link elements can bear tension or compression or both of them. Cables usually just can bear tensions. Okay. Everything is ready, so I can define my meshing size and start the mesh. Lines. You can see the lines here. I have to define the meshing size and allocate them to the lines. You can allocate meshing size even on your areas or volumes, but I choose lines. Meshing. Mesh tools is the summary of all of these options. You have all of the options here. So I want to define the meshing size. If I press the size line and I press OK, in this part I can define choose one of these options to define my mesh size. The first is that when you want to, for example, define mesh that are for example, the size of them must be, for example, 100 millimeters, so you have to insert 100 millimeters in this part. And the second, you can define the number of divisions along the line. For example, if I insert 4 along this line, I have 4 elements. And a space means that, for example, when you insert a space, a number, for example 2, your mesh will not be exactly the same size. And for example, if I insert, for example, 2 here, the first mesh and the second mesh is, for example, the last mesh and the last element size will 2 times greater than the first element here. For example, I inserted 4. Okay, and these are the others. For example, define the degrees, for example, along the arcs, and okay, I don't need it. Even we can, for example, choose the good view to select multiple lines. For example, here set box. For example, choose multiple lines by box. Okay. I defined my meshing size before. I don't want to define them again. Before even I create these volumes, first I have to think about my meshing and mesh size. So take it in account in your modeling, because it's really important. Your partition can be defined when you based on the meshing and meshing size. So I define all of the meshing size here. Then I have to choose the element specification that I'm going to mesh. My element type is number 1. I want to, for example, define my concrete. Real material number for concrete was 1 and real constant was 1. You can see here element coordination system. You can define multiple coordination system, as I told you before, for that can help you in some models. I don't need it in this model. Okay, and I have to mesh in this part. I want to do, for example, mesh my concrete, and concretes are my volumes. I have two options here, TED. And when you choose TED, your elements will be disordered and will not have exact shape and size, and they will not be exactly equal. But when you choose hex, your mesh will be more neat, and usually your mesh are block shape. And I have again two options here: sweep, mesh an area, and like extrusion, it repeats the pattern along your line. Again, I don't need it, and I choose mapped. For concrete, you try to use mapped shape, because concrete solid 65 will work better and exact when your elements are block shape. Mesh, I can choose it single by single or by box, or I pick it up. I finished my meshing, so I want to start the meshing of my tendons. And for tendons, again, I have to define the specification of the tendon. My tendon is link 180, material number is 3, and real constant is 2. Okay, so my tendons are lines. I have to choose here line, and plot lines, and mesh lines. If I want to select these lines, I will face some difficulties, because I have other lines here that related to our volumes. So I have to deselect these lines in order to mesh my lines easier. For deselecting these lines, I have to here go to select entities and lines, here unselect, and various pattern for your unselection, attach to by location. I choose attach to because these lines are not attached to any areas. So if I unselect all of the lines attached to areas, just these lines will be remain. Okay, plot lines. Yes, here is my lines. That's it, my lines are defined. I want to, for example, mesh these 4 sets of tendons. Again, I will choose line, mesh, box. Okay, I choose all of my lines, so I press OK. So my lines are meshed plot elements. Here is my tendons. My meshing is finished, but the end blocks remains. In order to define my end blocks, I don't need a new mesh. I can just modify this mesh and change the element type and material type. In order to define this, I choose a better view. Yes, I select these elements. Right now, page full. Okay, box. Here is my volume elements. For modifying these elements, I have to again go to modeling, move, modify, and elements. Modify attribute. Here I choose all elements around my tendons. No link, no. Okay. Okay. Element type must be material type must be changed to 2. And again, plot elements. Again, material type must be also changed to 2. I want to ease the selection, so for example select elements by attribute material number 2. Okay, plot elements. So I have to change the material type of these elements to 2. Box. Okay. Element type. Okay, 2. That's it. Plot elements. Select everything. Plot elements. You know, when I change the material number, my element change to a different color. In order to do this, you have to go to plot controls, numbering, and in this part you have to choose material number and color only, or color and number. For example, if I choose color and number, you can see the node number and also the elements number, the material number. For this is, for example, 3. You can see some 1 here. I don't want to be 1. I choose color. The other important option in plot controls is excuse me, here, size and shape. Enable this tick, because when you disable this tick, plot elements, the section of your link elements will be hide, and this option is really good when your elements are pipes or beam and they have a more complicated section. Okay, and here you can see that there are some volumes here, and I meshed these volumes, but these volumes are not bound together. For example, in some parts of my structure, these volumes are like monolithic part of my structure. These are my main segments. For example, this is the first segment, second segment, third and fourth segment. I have to unite this volume and make them as a monolithic part of my structure. In order to unite this volume, I have to merge node at interfaces of these areas on volumes. So I have to first select these volumes and my segments. First I go to the entities, line, volumes, my non-peak from full, box, okay, plot, volumes, I want to reach from volume to the nodes of these volume, and this next step is that I have to select the elements that are attached to these volumes. Elements attached to volumes, okay, plot elements, and the next step is that when you see here the nodes, I have more nodes here, and I need to select the nodes which are attached to my elements. Plot nodes. Here, if you see the node numbers here, you can read all of these numbers, but this number cannot be read very good. The reason is that I have 2 nodes in this part, and I have to unite and make these double nodes to a single node, and this would be and with merge option I can do this and unite these two nodes. Here I have to go to numbering controls, merge items, and this is the main window of merge items. It has some tolerance. For example, sometimes your nodes are not exactly at the same place, and for example their distance is less than 1 millimeter. For example, if you insert one, these two nodes will be merged and become a single node. And also here I have lowest or highest number. It means that when the nodes are merged, the new number of the node will be the greatest number or the smaller number. I no need to fill any blanks, and I press OK. When again I plot the nodes, you can see that all of the nodes can be read. You have to do the same for other part of the sections and also for your tendons. Lines. Again, I have to choose the lines of my tendon. Lines attached to areas, unselect, OK. Plot lines. Again, select entities, elements attached to lines, plot elements. Excuse me. Full attached to lines. OK. Plot elements. And select entities, nodes attached to elements. OK. Plot nodes. Again, I have the same problem in this part. I have to again merge the node at their interface. OK, that's finished. Plot nodes. Select everything. Plot control, numbering. Okay, that's it for this video. I will discuss the entire modeling process in next and upcoming videos. Thank you for watching. Don't forget to subscribe.